Hi, I'm Jim. This time, I'll be explaining one fascinating solid figure, the pyramid.
A pyramid is a polyhedron such that the faces are triangles which have a common vertex. If you say polyhedron, it is a three-dimensional figure with flat polygonal faces, straight edges, and sharp corners. The triangular faces are called lateral faces. The apex of a pyramid is the vertex at the top, which is opposite the base. It is the point where all the lateral edges meet. The base of a pyramid is a polygon of any number of sides. The pyramid, like prisms, is specifically named according to its base. If the base is a triangle, then it is called a triangular pyramid. If the base is a rectangle, then we have a rectangular pyramid. It's a pentagonal pyramid if the base is a pentagon, and so on. The altitude or height of a pyramid is the perpendicular distance from the apex to its base. The slant height, on the other hand, is the distance along a lateral face from the base to the apex, along the center of the face. So here, the green line segment represents the altitude, while this red one represents the slant height. Let's compare an oblique pyramid to that of a right pyramid. An oblique pyramid is one where the apex is not directly above the center of the base. Also, the lateral faces of an oblique pyramid are not congruent triangles. On the other hand, for the case of a right pyramid, all the lateral faces are congruent triangles. This indicates that the apex is directly above the center of the base. To find the total surface area of any pyramid, be it oblique or right, or regular or not, it will be very helpful to sketch the net. A net is a two-dimensional representation of a three-dimensional figure that is unfolded along its edges, so that each face, the figure is shown in two dimensions. Again, this approach is very helpful when we happen to forget the formulas for the area. Like in this case, for this square pyramid, we sketch first its net. Then we see here that the total surface area is the sum of these 5 areas. The area of the base B and the areas of these 4 faces. Again, the total surface area of any pyramid is equal to the area of the base B plus the sum of the areas of all the lateral faces. Note that all the lateral faces are all triangles. Now, using the concept of the net in the total surface area, we'll derive a formula that we can use to determine the total surface area of any regular pyramid. Again, this is the net of this given square pyramid. Let's denote the height by h and the slant height by L. Here, we also denote the side of the square base by A. Referring to the net, we'll derive a formula for the total surface area. Note that for any regular pyramid, all the lateral faces are isosceles triangles. An isosceles triangle, of course, has two equal sides. Again, the total surface area is equal to the area of the base B plus the sum of the areas of all the lateral faces. Here, the area of each triangle is denoted by A. Hence, this is now A plus A plus A plus A, which is of course equal to 4A. Specifically, the area of each isosceles triangle is 1/2 base times height. So, it is 1/2 AL. Note that this side is the base of this isosceles triangle, and this also measures A. Then we can regroup the factors of this term and would see that 4A is the perimeter of the base. Therefore, the total surface area can be calculated using this formula. T is equal to B plus 1/2 P times L, where B is the area of the base, L is the slant height, and P is the perimeter of the base. We can actually use this formula to calculate the total surface area of any regular pyramid. On the other hand, for the volume, it is V is equal to 1/3 area of the base times height. Let's now examine specific cases of a regular pyramid. Again, a regular pyramid has a base which is a regular polygon and has lateral edges which are all equal in length. First, let's take the case of this triangular pyramid. The base of a triangular pyramid is of course a triangle. We'll now derive the specific formulas for its total surface area and volume. For the total surface area, again, it is the sum of the area of the base B and 1/2 P times L. Here, P is the perimeter of the triangular base and L is the slant height. Note that the base is an equilateral triangle with side S and with height A. Being a triangle, the area of the base is 1/2 S times A, S being the base of this triangle and A being the altitude. For the perimeter of this triangular base, denoted by P, since S is the length of all the sides, then the perimeter is 3S. Therefore, the total surface area of this triangular pyramid is given by this formula. T is equal to 1/2 A times S plus 3/2 times S times L. Now, let's derive the formula for the volume of this triangular pyramid. Here, we denote the altitude or height of this pyramid by h. The volume of a pyramid is given by this equation. V is equal to 1/3 base times height. But as we have seen earlier, the area of the triangular base is 1/2 A times S. Therefore, the volume of this triangular pyramid is given by this formula. V is equal to 1/6 times A times S times H, where A is the altitude of this triangular base. S is the side of this equilateral triangle. And H is the height of the pyramid. Let's examine a square pyramid. A square pyramid has a square as its base. Again, we'll use this general formula for the total surface area. T is equal to B plus 1/2 LP. Here, B is the area of the base, P is the perimeter of this square base, and L is the slant height. Denoting the sides of its square base by A, the area of the base B is A squared. For this second term, 1/2 LP, or sometimes written as 1/2 P times L, the perimeter of the square base P is equal to 4A, because note that the perimeter is the sum of all the lengths of these four sides, A plus A plus A plus A. That's why this is now 4A. Therefore, the formula for the total surface area is now given by T is equal to A squared plus 2AL. Again, A is the side of the square base, L is the slant height of the pyramid. For the volume, the general formula is again given by this equation. V is equal to 1/3 times the area of the base times height. But since the area of the base is A squared, the volume of a square pyramid can be calculated using this formula. V is equal to 1/3 A squared H. Again, A here is the side of the square base, and H is the height of the square pyramid. Let's have the case of a pentagonal pyramid. A pentagonal pyramid has a pentagon as its base. Using this general formula for the total surface area, we'll derive a more specific one. Again, in this figure, H is the height of the pyramid, L is the slant height, and S is the length of each side, while A is the apothem. The apothem of a regular polygon is a line segment from the center to the midpoint of one of its sides. Now, the base being a pentagon has an area of 5/2 A times S. The perimeter, on the other hand, is 5S because each of the 5 sides has a length of S. Therefore, the formula for the total surface area is now given by T is equal to 5/2 A times S plus 5/2 S times L. Again, A is the apothem, S is the length of the side of the pentagonal base, and L is the slant height. For the volume, again, the general formula is given by this equation. But since the area of the base, P, is 5/2 A times S, the volume of a pentagonal pyramid can now be computed using this formula. V is equal to 5/6 times A times S times H, where A is the apothem, this being the apothem, S is the length of each side of the pentagonal base, and h is the height of the pyramid. I hope you learned something from this video. In my next video, I'll be discussing about another fascinating solid figure, the cone. Thanks for watching.